what kind of intruders do we have? We have two types, passive and active. Passive is when they just want to see the data which they're not authorized to see. So they just want to read files. They are not authorized to read. And what do you think the active intruder will do? So these guys are passive because they're not doing actually anything. They're just reading. And the active intruders will actively do something, such as, well,
Change the data or corrupt it?
yes, so they would modify the data, but they're not authorized. So they want to make unauthorized changes to the data, which is more serious than just seeing the data. So we have several categories here of intruders that we can think of. The first one is casual. Casual prying by non-technical users. This is just like go and look at our colleagues' computer screen and read their emails, or look at the files that they're looking at, or something like that. This is still an intrusion, though it's non-technical, but these occur often in office environments. The next one, snooping by insiders. These are technical people who consider it a challenge to break the security of the system. So they consider it a personal challenge. This is like hackers, like, let's see exactly how smart we are and can we break into the security of this system just for fun. So we have that category. And these are usually called insiders because we're talking about people that work in that organization. So they are familiar with the internal environment, and it's much easier for them to actually break into the system. Then we have the third category, which is even more serious, determined attempts to make money. This is, for example, programmers that work for the bank, for example. And let's say change the software to keep a fraction of the penny for themselves or something like that on each transaction. So this is intentionally modifying software of the bank to try to make money or to steal money through electronic transactions. And then the next category is commercial or military. Commercial or military espionage. So these are like well-funded adversaries. So they have the money already, and they're attempting to steal trade secrets or military secrets of other governments, of other countries, technology, and other ideas. So as you can see, we as the designers of operating system trying to keep it secure might be dealing with some well-funded, well-educated, smart, and motivated adversaries. So we need to think what we can do and how we can protect the system. So let's look at basics of cryptography. Cryptography is one very old method which can be used to protect information. So the cryptography is a way to take a message called a plain text message and encrypt it in such a way so to produce ciphertext that can be only decrypted or deciphered by authorized parties in order to obtain back the original plain text. So the purpose of cryptography is to take a message called plain text and encrypt it into a ciphertext. In such a way that only authorized people can read it. How can they read it? Well, they need to convert it back to plain text. They need to follow a certain algorithm called decryption algorithm and need to have a certain key to decrypt the ciphertext into a readable format. For all others, the text is incomprehensible. So the ciphertext is unreadable. It looks like a bunch of junk if you try to read it on the network. So let's say if we take a tool that will record packets from the network and try to read what's inside the packets. We can do that. Everybody can do that who is connected on the network. Once we start reading, most of the things are in plain text, like HTML pages, texts, pictures, unless they are encrypted. If they are encrypted, it basically looks like a bunch of junk. A bunch of symbols, kind of like when your printer is broken and you try to print something and it looks like junk. That's how the ciphertext looks like if you try to read it on the network. So what we have is P is the plain text. Then we have E. E is the encryption algorithm. Then we have K for E. This is a key which is used in order to produce the ciphertext. So we have an algorithm that we follow. In order to use this algorithm, we need a special key. And this is the key for encryption. That was KE. C is the ciphertext. And the C is equal to the plain text encrypted with the encryption key by following the encryption algorithm. So that's what this is here. C is equal to plain text with the key applied to it through an encryption algorithm. If we want to obtain back the original plain text, what we need to do is apply the decryption algorithm. Now, it also uses a key. So KD will be the key for the decryption algorithm. Now, if we want to obtain back the original plain text, we need to take the ciphertext, apply the decryption algorithm, apply the key, decryption key, and decryption algorithm to obtain back the plain text. So that's what that is. We take the ciphertext, decryption key, follow the decryption algorithm to obtain back the plain text. Now, we have two keys here. As we can see, can these two keys be the same thing, or do they have to be different? What do you think? Look at this.
Could it depend on the encryption? Or is it always the same?
Okay, so one student is saying it depends on the encryption algorithm. So yes, they can be the same thing. If they are, it's called a symmetric key. And that's what we have here. If they are different, it's not symmetric, and there is no way that once this is encrypted, we can go back the other way. It's just very difficult to do that. So there are special algorithms that use two keys, which are different for the encryption and for decryption, to make it more secure. But if we look at a very simple cryptography method, which is called monoalphabetic substitution, is what we have here, we will see that the encryption and the decryption key is the same.